In this question number 3, this is period 3 chemistry. So sodium, magnesium, aluminium, phosphorus, sulfur, and chlorine and argon. But when we talk about the oxide, the syllabus specifically stop at sulfur because chlorine can actually form quite a lot of oxides. We don't really deal with it in the we don't really deal with it in detail in the AS syllabus, but we do have some oxides of chemistry when they form ions, like the sodium chloride 1, sodium chloride 5 as well. Disproportionation case studies with the halogens. In this first question, give the formula of the oxide form when each element is heated in air. So we're going to have Na2O and MgO. As you know about this ionic oxide, we talk about the valency from your O-level or IGCSE days. So you know the valency follows the charge of the ions, and then you do the crisscross, and this will tell you how many of the ions you have. So you must have 2 of the Na plus and 1 of the O2 minus, such that you get Na2O. On the other hand, when you have MgO, Mg2 plus O2 minus, 2 and 2 for the valency, 2 and 2 for how many, but you need the simplest whole number ratio, so you only have 1 Mg2 plus and O2 minus. Al3 plus O2 minus, based on their valency, you get Al2O3. Now onto the phosphorus and sulfur. When you heat them in air, the sulfur is not going to go all the way to sulfur trioxide. You only go to SO2. Remember how difficult it is for you to actually go to SO3. You need contact process. You need equilibrium. You need conditions, certain conditions of temperature and pressure. Not going to happen when you just heat it in air. Alright? So that's why I start at SO2. As for the phosphorus one, depends on the oxygen. If you have not enough oxygen, it's going to go P4 or 6. But if you have enough oxygen, and they didn't mention in excess oxygen or not enough oxygen, so I'm going to say in excess oxygen, you can have P4 or 10. So both of them are entirely suitable and should be correct here, but not SO3 there, because to get SO3, you do really need some sort of equilibrium setting up in industry. Unless you are in the upper atmosphere, and that is not true here. You're just heating up the element in air. In part 2, describe what you would see when sodium and sulfur are each heated separately in air, and give an equation for each reaction. Now the equation is probably the easier one to do first. So sodium plus oxygen, and you will get sodium oxide and Na2O. We got to balance everything we write. So 2 sodium there means 2 sodium there. And 1 oxygen atom there means I have to balance this with 1 oxygen atom. But this is a molecule, so half times 2 give me 1 oxygen atom, and that equation is balanced. I don't need a stat symbol. The question didn't ask me for the stat symbol. Sulfur plus oxygen, your first step in the contact process is to roast sulfur in oxygen to give you the sulfur dioxide, and then this sulfur dioxide can go to sulfur trioxide in an equilibrium step that you need to talk about Le Chatelier's and certain conditions to get a good yield of SO3. Now onto the observations. So what you would expect is as you form the Na plus cations, and we know about the Flam color, the Flam test is now in the AS syllabus. So back then it wasn't, but now in the AS syllabus, even the IGCSE, GCSE and O-level, you have the Flam test of Ma plus, and that will give you the yellow flame. So we know that this will burn with a yellow flame. So you see a yellow flame as the sodium metal burns in oxygen, and you get the Na plus cations. Of course, then as you form this sodium oxide, instead of this metallic color of sodium, and then you will get a white solid forming. So you get a white solid formed as a product. On the other hand, this sulfur there forms this simple covalent molecule. So obviously you don't have the Flam test for cations because you don't have a cations. These are simple covalent molecule. But the sulfur actually burns in oxygen in a very characteristic color. So it burns with a blue color flame. So with a blue flame, this is a very, very special kind of color. If you had the opportunity to actually see this, you should try and see it, and you can check out YouTube for this color. Actually, it's actually pretty cool there. Okay. Now to the next question. The oxides show variations in their behavior. When you add them to water, it's either whether they're acidic oxide or basic oxide. So if they are acidic oxide, they're going to give you acidic solution. If they are basic oxide, if they dissolve in water, you're going to get alkaline solution or basic solution. So place the symbols of the elements So the period 3 oxide, this symbol here, sodium oxide and magnesium oxide are basic oxide. So that thing is going to be Na2O and also MgO. Al2O3 is amphoteric oxide. It is actually insoluble in water, but then it's amphoteric because it reacts with acids and also bases to give you salts and water. So acidic oxides are the non-metal oxides, the P4O6, P4O10, as well as SO2 there. Of course, SO3 is also acidic, but they were not from your list. They were not from your list in A part 1, so we cannot use SO3, but depending on which one you put in your list, whether you put P4O6 or P4O10, that depends on what you had written down here. State the bonding present. In this basic oxide, you have ionic bond. So they just want the bonding, they don't want the structure, not the structure. Be very careful. Bonding is not structure, structure is not bonding. And you have covalent bonding in the non-metal oxide there. Now onto the reactions of aluminium oxide. This is a key part of the definition. For this amphoteric oxide, you should at least know how to write them so that you'll be more prepared with them. Al2O3 plus HCl, I'm going to get AlCO3 as my salt, and I produce water. Our equation must be balanced, so 2 aluminium on the left, so 2 AlCO3, 6 chlorine on the right, so 6 HCl, 6 hydrogen on the left, so I need 3 H2O to give me 6 hydrogen, 3 oxygen there, 3 oxygen there. This equation is balanced. It is the sodium hydroxide one that is actually quite tricky to balance. There is more than one way of writing this equation, but the way I normally write it is in this format. You would expect to get aluminium hydroxide. This is a white precipitate that you get since your O-level, GCSE or IGCSE level practical. You get a white precipitate forming when you have sodium hydroxide in the presence of Al3 plus or Al3 plus in the presence of OH minus. This white precipitate dissolve in excess NaOH, and then it will dissolve in excess. That means you don't get this anymore. What you get in excess is this aluminium with 4 hydroxide. Al3 plus minus 1 times 4 is minus 4. Overall will be minus 1 charge. So what you get there is AlOH4 and then minus 1 charge there. Very important stuff there. This is your colorless solution that you get when this white precipitate that you form initially, hydroxide and Al3 plus, the white precipitate dissolve in excess sodium hydroxide or dissolve in excess hydroxide to give you a colorless solution there. So hopefully that makes sense to you. Perhaps I can just move this down somewhere so that we wouldn't lose that. Just give me a minute. Not really, no. Okay, I'll just write it down on the far left there. We got to balance our equations. You will see that I've written down as the plus and minus the ionic form so that we are not easily confused. But if you don't want that form, you can just remove the plus and the minus, and that will be entirely fine as well. So this is together as one compound. When we balance our equation, we'll have 2 aluminium on the left. So I will have 2 lots of this salt, the Na plus Al 4 times OH minus overall charge of the anion. Now I have 2 sodium. I have to put 2 NaOH. And now you will see that I have 4 hydrogen times 2, 8 hydrogen and 8 oxygen. Clearly, I don't have enough oxygen and I don't have enough hydrogen. I cannot be producing water there. Instead, for this particular equation, your water has to be on the left for you to balance this equation. So you have 2 hydrogen, you need 8 hydrogen. So you have another 6 more hydrogen from 3 water molecule. 3 oxygen plus 2 oxygen is 5 oxygen, plus 3 is 8 oxygen. This is the way to balance the equation with Al2O3 and NaOH. I did say earlier that there is actually another possible equations. I don't normally remember that equation, but you have written down something that makes sense and you check the marking scheme is fine, then I'm sure it's fine. All right, but this is the usual equation I normally think of, and that follows through from my Al3 plus qualitative analysis case study, and I get this colorless solution when it dissolve in excess NaOH there. Now part C, how does the presence of an impurity, so you need to name this impurity and you need to explain. So there are 2 bits to that thing here. This is carbonaceous, so this means carbon containing fuel. This is now in environmental chemistry. I know this for a fact. It is in the O-level 2023 syllabus onwards that specify exactly, even in the combined science syllabus, they said that sulfur dioxide can come from burning carbonaceous or carbon-containing fuel that contain traces of sulfur impurity. So this is sulfur as a solid present as an impurity in carbon-containing fuel. So combustion of the fuel, combustion of carbon-containing fuel or carbonaceous fuel, basically hydrocarbons with sulfur pollutant or with sulfur impurities, produce sulfur dioxide, produce SO2 gas. And what does this SO2 gas do? So the SO2 gas gets oxidized by NO2 gas in the upper atmosphere, forming acid rain, forming SO3 actually, forming SO3 gas that can then form acid rain. So they are not asking for equation here, but if I write equations instead of writing a lot of words, that should have been acceptable as well. So first of all, when you burn sulfur, you're going to get SO2, and that SO2 can escape to the upper atmosphere. And the key reaction is the SO2 react with NO2, and you're going to get NO plus SO3. This is not in equilibrium. You are not in industry. This is not man-made. This is nature in the upper atmosphere. The NO2 is actually a catalyst because the NO can regenerate back the NO2 by getting oxidized with the oxygen in the air. But my focus here is to show how does this burning this sulfur in the carbon-containing fuels lead to acid rain. So I will skip that step there. This will give you H2SO4, which is your acid rain. It is, after all, chemistry exam. If you don't feel like writing a lot for your explanations, you can obviously, write some equations, and that will substitute all the words here as well. But you got to name the impurity as that is required in the question there. And that's the end of that 14 marks inorganic question.